Assalamualaikum and good day everyone. Today my team and I would like to present a topic about manufacturing and quality controls in pharmaceuticals using a Q-test. A Q-test is a test that we have previously learned in Chapter 2, Evaluation of Experimental Data. So without further ado, let's go. So before we get into the video, I would like to introduce my team members. My team members consist of Amirah Huda binti Asfa, Alia Marina binti Muhammad Sani, Miza Maisara binti Abdul Hamid, Ria Idina binti Muhammad Haider, and me, Nur Izzah Karina binti Kamar Sani. So what is a Q-test? A Q-test is a simple statistical test to determine if a data point that appears to be very different can be discarded. So in Q-test, we will be comparing Q-calculated or Q-experimental with a Q-table. A Q-table is usually provided to us, and it is actually the reference that lists critical Q-experimental or Q-calculated at different confidence level, such as 90%, 95%, and 99%. So the equation that we use to calculate Q experimental or Q calculated is A over W, and it is in modulus. A refers to the gap between outlier and the one closest to it, and W refers to its range. So if Q experimental or Q calculated is bigger than Q table, it can be rejected, and it will be called an outlier, which could be the result of an undetected error. So earlier we have learned that if a data can be discarded, it means an error has occurred. Let's look at types of error. We have two types of error. First is determinate errors, or some people call it systematic error, and another one is indeterminate errors. Some people call it random errors. Let's look at it one by one. So determinate errors is a consistent error associated with faulty equipment or flawed experiment design. A faulty equipment is just an equipment's problem. A flawed experiment design, however, is an experiment that has error in either setup or plan or methodology that can cause an invalid results. So it arises from a known source, therefore it can be avoided or corrected. And last but not least, it has three sources of error, which are instrument error, personnel error, or method error. So an example of instrument error is uncalibrated glassware. How do we fix that? Maintain the equipment. Next is personnel error. The example of that is incorrect reading of meniscus. We can fix that by training or a little discipline. And last but not least is method error. Something like impurities in reagent. How do we fix that is proper method selection. So next is indeterminate errors or random errors. It occurs when a system of measurement is extended to its maximum sensitivity. So what does that mean? It means that the measurement was already successful. So random errors originate from unknown sources, therefore it cannot be eliminated. A little fun fact, systematic error, it affects average, while random error does not affect average. So yes.
Now, I will explain the significance of the Q-test in pharmaceutical manufacturing and quality control. First, the Q-test helps prevent false rejections, which means it reduces the unnecessary disposal of good quality product batches. Sometimes, an unusual result may occur because of random laboratory errors instead of an actual product defect. By identifying these anomalies, the Q-test helps save compliant batches and reduces unnecessary financial losses. Second, the Q-test plays an important role in safeguarding patient safety. It ensures that genuine out of specification or OOS results are correctly identified. This prevents substandard or incorrectly formulated pharmaceutical products from reaching consumers, helping to protect public health. Third, the Q-test eliminates human subjectivity. Instead of relying on personal judgment or selective ignoring certain data, it uses objective statistical calculations to determine whether a data point is truly an outlier. This creates a consistent and standardized approach for all laboratory analysts and chemists. Next, the Q-test is specifically designed for small sample sizes, typically between 3 and 10 replicates. This allows laboratories to maintain high statistical reliability while minimizing the time, cost, and resources required for testing. Finally, the Q-test supports regulatory compliance and audit readiness. It aligns with international standards such as Current Good Manufacturing Practice or CGMP and USP Chapter 1010 guidelines for data treatment. In addition, it provides a clear and traceable record data evaluation, making it easier to demonstrate compliance during inspections by regulatory authorities such as the FDA and NPRA. In summary, the Q-test improves data reliability, ensures product quality, protects patient safety, and supports regulatory compliance, making it an essential tool in pharmaceutical quality control.
I will talk about the theory. First, what is the experimental Q? We can find experimental Q using the formula CAP per range. The value obtained from the experiment or the value we get from the calculation. What is the critical Q? Critical Q is the accepted value or standard value from the theory or reference that we should get. The critical value already obtained in the standard table. The comparison between Q experiment and Q critical is used to determine whether the experimental result is retained or rejected. What is the meaning of range? Range is the difference between highest and lowest outlier. If the Q experiment is less than Q critical, the result is retained because the value within the expected range. But if Q experiment is large than Q critical, the result is rejected and the highest outlier need to be removed. What is the meaning of gap? Gap is the highest gap difference between outlier. If a smaller gap we get, it will be more accurate and near to the theory value. But if we get the answer is largest gap, the answer will be less accurate and include experimental error and very far to the theory value.
Next, we are going to take a look at the methodology and the example results. So, a quality control of chemists tests 5 tablets from a batch. So, the measured mass of active ingredient like paracetamol in milligram is 498 milligram, 501 milligram, 499 milligram, 502 milligram, 475 milligram. So we have a 5 step to find the Q test of this question. So first is we need to arrange the order from the smallest to the highest. So as you can see, I already arranged the order. And then second is we need to find the each gap calculation of our data. So we get 23, 1, 2, and 1. And number 3, the highest gap is the outlier of the data. So the outlier is 475. And then step 4, we need to find the QASP, whereby QASP formula is A divided with W. W is a range whereby the highest value will minus with the smallest value. So the answer is we get 0.852. We move at the last step, which is we are going to take a look at the number of observation. So from our data, we have a 5 number of observation. So we can take a look at the table beside. So at the confidence 95%, it is 0.710. So if the QASP is more than the Q table, so the data will be rejected. So from our result, 0.852 is more than a Q table. So at 95% confidence, the data 475 milligram is rejected.
In conclusion, the Q-test is an important statistical use in pharmaceutical quality control to identify and evaluate outliers in small data sets. It helps analysts distinguish between genuine experimental errors and valid test results, ensuring that only reliable data are used for decision making. By reducing human bias, improving data accuracy, and supporting regulatory compliance, the Q-test contributes significantly to product quality and patient safety. Therefore, the application of the Q test plays a vital role in maintaining the reliability and integrity of pharmaceutical testing processes.